today's lesson, you will need two fraction walls, one already cut up into pieces and the other left uncut. You can find a link to my template in my video description below. Please note that because this is a pre-recorded lesson, it does not replicate the exact format or full suite of Singapore mathematics pedagogy. However, it does apply the concrete pictorial abstract CPA approach used in Singapore mathematics teaching. If you would like your child to experience the benefits of Singapore mathematics taught by a Singapore-trained mathematics teacher, please email me at conceptuallab@gmail.com. Conceptual is spelled with a K as the first letter.
Today we are going to compare unit fractions. So you should have this fraction wall in front of you together with another fraction wall that has already been cut up into these individual pieces because we are going to use them to make comparison today. If you have a ruler, place your ruler upright and pull out one piece of fraction from each row and put it against the ruler. Like what I've done here. All right. What do you notice about these fractions as we look at them and compare them with each other? You'll probably realize that other than the color changes, all right, the numerator is the same in each of these fractions. The denominator changes. The denominator actually, you can say increase by 1, or you can just say they increase as we go downwards. What else do you notice? You notice that the fraction gets smaller, right? So what relationship can you see between the size as well as a number in each of these fractions? Do you think the numerator affects the size? Or do you think the denominator affects the size? The denominator actually affects the size, and we are going to discover more about why that's the case. All right. So these fractions have a third, a quarter, all the way each of these, okay, they are called unit fractions. So unit fractions are fractions that have 1 in the numerator, like all these fractions, and the denominator is different. We can see from this pattern that the greater the denominator, the smaller the fraction. So we can say that the size of fraction becomes smaller as the denominator becomes bigger. Okay, but why does the fraction become smaller as the denominator becomes bigger? I'm going to put all these fractions pieces back into the fraction wall. You don't have to do that because you should already have your fraction wall with you. So now I have back my fraction wall. This is a whole, all right? A whole is something that is complete, it has not been cut up, but it can also be made up of parts, like what we see over here, all right? Each of these row, let me use, each of these row, all right, is actually a whole, and these wholes are made up of smaller equal pieces in the fraction wall. All right, so if we So if we look at this whole that is made out of two equal parts, half and a half, and compare this whole with with this whole that is made out of fifths, what do you notice that is different other than the colors and the numbers in the denominator? The number of parts being cut up is different. All right. If you were to compare each whole, any two wholes, like this whole over here that's made out of quarters with this whole over here that's made out of nines, you will notice that other than the color and the denominator, the number of pieces being cut up is different. All right. So if you have a whole and you cut the whole into two pieces, compare with a whole that you cut out into four pieces, and these pieces must be equal, do you think a whole that is cut up fewer times will have a larger piece than a whole that's cut up more times? Do you see that the more you cut, the smaller the pieces? And size of each pieces in each whole is actually determined by the number of pieces it is cut into, which is also the same as the denominator. So the denominator tells you the number of parts in a whole, okay? It also means that the denominator tells you the number of equal pieces that have been cut up in each whole. So the more equal pieces you cut from a whole, the smaller each unit fraction is. The more pieces cut in the whole, the smaller each piece. Now we're going to look at some questions. So we're going to compare half and a third. All right, so I have two wholes over here. How many pieces will I have to cut this whole to make halves? I have to cut two equal pieces. All right, I'm going to try to do it as equal as possible. So two equal pieces of half. And for this whole, I'm going to cut them into three equal pieces as equal as possible. All right. So when you compare these two fractions, you compare half. So you compare half and a third. It's very obvious that half is bigger than a third. Why? Because half, the denominator tells us half is cut from a whole that has fewer pieces than a third, which is cut from a whole that has more pieces. The more you cut, the smaller each piece. All right. So we can say half is bigger than a third. Now, when we look at the example number 2, a quarter compared with 1/8. Which fraction do you think is smaller? Will it be a unit fraction from a whole that's cut fewer number of times, or a fraction from a whole that is cut more number of times? Remember, imagine the more you cut, the bigger or the smaller the pieces is. 1/8 should be smaller than a quarter because an 8 comes from a whole that's cut into more equal pieces as what we can see from this fraction wall up here. Okay, each eighth is smaller than a quarter because 8 is cut from a whole that has more smaller pieces.